Look at your skin right now. Go ahead. Whatever color it is, wherever you fall in that spectrum from barely there beige to deep, rich brown, that shade has a story behind it. A very old story. A very dramatic one. And the thing is, nobody picked it. Not your parents, not your culture, not some ancient tribal preference for a particular look. The thing that determined the color of your skin was decided by a star 93 million miles away that has never once thought about you and never will. This is the story of how human skin went from a single starting color to the enormous range we see today. And the answer involves cancer, reproductive failure, a dietary collapse that nobody planned, and a genetic mutation so recent it's younger than your kitchen table. Not metaphorically, literally younger. Here's where we start. Every human being alive today, no exceptions, descends from a dark-skinned African population. Not some of us, all of us. Roughly 300,000 years ago, when Homo sapiens first emerged on this planet, the entire species shared one skin tone. Dark, heavily pigmented, rich in melanin. There were no light-skinned people anywhere. The genetic variants that produce pale skin didn't exist yet. They hadn't been invented. So if you've got light skin and you're sitting there feeling like that's just your natural default state, the baseline, the original setting, here's the correction. It isn't. Dark skin is the original. Everything else is a modification that came later under specific pressures in specific places for specific biological reasons. So why does melanin exist in the first place? Because the sun is trying to kill you and has been for the entire history of life on Earth. UV radiation is the invisible energy the sun continuously throws at our planet, and it is genuinely dangerous. It breaks chemical bonds. It damages DNA directly. It causes mutations in your cells, and enough mutations in the wrong places over enough time means cancer. Melanoma specifically, which is among the most aggressive cancers a human being can develop, melanin is your body's answer to that threat. It's a natural pigment that absorbs UV radiation before it can reach the deeper layers of your skin where your DNA actually lives. More melanin means more protection. In equatorial Africa, under some of the most intense sustained UV on Earth, this wasn't optional. Dark skin wasn't a preference, it was a survival requirement, selected for relentlessly over hundreds of thousands of years because the people without it died more often before reproducing. But here's the part that most people don't know, and it's honestly one of the more quietly terrifying things about human biology. UV radiation doesn't just attack your skin, it also destroys something flowing in your bloodstream, a molecule called folate, which is vitamin B9. And folate is not something you can afford to run low on, especially during pregnancy, especially in the earliest weeks before most women even realize they're pregnant. Folate is what the embryo uses to form the neural tube, the structure that becomes the brain and spinal cord. Without enough of it, the neural tube doesn't close correctly. The outcomes are severe: neural tube defects, developmental abnormalities, miscarriage. So darker skin in sun-intense environments wasn't just protecting against cancer. It was also protecting pregnant women from folate destruction, which was protecting their unborn children from catastrophic developmental failure. Two completely separate survival pressures, both pointing at the same solution. Evolution doesn't usually get to be this efficient. This was a rare clean win. Now here's where things get complicated. Between roughly 70,000 and 100,000 years ago, groups of Homo sapiens started leaving Africa. Not in a single organized wave. No one held a meeting. It was the slow, generational kind of movement where one group drifts a little further than their parents did, and their children drift a little further still. Over thousands of years, humans spread into the Middle East, across Europe, deep into Asia, eventually into the Americas. And as they moved further from the equator, the UV environment changed completely. At higher latitudes, sunlight hits the Earth at a shallower angle and passes through far more atmosphere before it reaches you. UV radiation gets filtered out. Days shorten. Winters arrive. The sky stays overcast for months at a stretch. In northern Europe or northern Asia, the UV intensity is dramatically, radically lower than in equatorial Africa. And here's the brutal irony. All that melanin that was absolutely saving your life in Africa was now working against you. Not because of cancer risk, which dropped significantly at northern latitudes. Not because of folate destruction, which also dropped with reduced UV exposure. The problem was vitamin D. Your skin produces vitamin D when UVB radiation strikes a compound naturally present in your skin cells. It's essentially solar manufacturing. Your body uses sunlight as raw material to produce a molecule it desperately needs. And vitamin D is not remotely optional. It controls calcium absorption. Without it, calcium doesn't reach your bones properly, regardless of how much you consume. In children, severe deficiency produces rickets, which softens and deforms the skeleton. bows the legs, flattens the skull, and stunts growth entirely. In women, it weakens the pelvic bones, making childbirth extraordinarily dangerous. Death rates in labor rise sharply. The immune system degrades. Muscle function declines. This is not a minor inconvenience. This is cascading systemic failure across multiple body systems simultaneously. So now imagine a dark-skinned person in Northern Europe 40,000 years ago. Their melanin is working exactly as designed, blocking UV efficiently, perfectly calibrated for Africa. But in the pale northern light, that melanin is blocking the very UV their body needs to produce vitamin D. Their skin genuinely cannot distinguish between UV worth blocking and UV worth using. It just blocks. The result is inadequate vitamin D, weakening bones, children with rickets, women dying in childbirth, a slow, multi-generational decline. Evolution noticed. Mutations that reduced melanin production started appearing randomly in the northern population, as mutations always do. But instead of disappearing, they spread. Lighter skin meant slightly more vitamin D, slightly healthier bones, slightly better reproduction. Active outcomes. Generation by generation, incrementally lighter, incrementally lighter. The algorithm didn't change. The inputs did. For a long time, the scientific assumption was that this lightening happened slowly, over hundreds of thousands of years, a gradual steady drift as humans moved north. Ancient DNA research has completely dismantled that picture. Early European hunter-gatherers were still significantly dark-skinned even after spending tens of thousands of years at northern latitudes. The most famous example is Cheddar Man, a person who lived in what is now Britain about 10,000 years ago. DNA analysis published in 2018 found he very likely had dark to medium dark skin, dark curly hair, and blue eyes. A combination that looks almost impossible to modernize because we associate blue eyes so strongly with extremely pale skin. But 10,000 years ago, that connection didn't exist yet. The very fair skin common in northwestern Europe today appears to have spread widely only in roughly the last 6,000 to 8,000 years. In the full 300,000-year history of our species, that's barely the last 3% of the timeline. So what changed 6,000 to 8,000 years ago? The Neolithic Revolution. Farming. When humans transitioned from hunting and gathering to agriculture, their diet fundamentally changed. Hunter-gatherers were eating fatty fish, organ meats, shellfish, animal products rich in dietary vitamin D. Farming populations switched to cereals almost entirely: wheat, barley, rye, oats, carbohydrates. Their dietary vitamin D intake didn't just fall, it collapsed. Populations that had been tolerating moderately dark skin because their food was supplementing their UV-synthesized vitamin D were now almost entirely dependent on whatever their skin could manufacture from weak northern sunlight. That gap became critical. Even small reductions in melanin, even marginally lighter skin, became the difference between survival and deficiency-related death across generations. Farming also added another accelerant. Agricultural communities were large, dense, and sedentary, which meant that when an advantageous mutation appeared, it could spread through thousands of descendants in just a few generations, rather than crawling slowly through scattered bands of 50 people. Population density is basically a turbocharger for natural selection. The combination of dietary vitamin D collapse and dense interconnected communities essentially compressed what might have taken hundreds of thousands of years into a few thousand. That's why the archaeological record looks the way it does. Not a gradual slope, a sudden, visible acceleration. Here's something worth pausing on. Skin color isn't controlled by a single gene. There's no simple switch. Pigmentation is a polygenic trait, shaped by dozens of genes affecting how much melanin gets produced, what type of melanin it is, how melanin granules are distributed inside individual cells, and how the skin responds to UV exposure over a lifetime. And the most remarkable part of all of this is that East Asians and Europeans both evolved significantly lighter skin independently, but they used almost entirely different genes to get there. Different populations, different continents, different genetic pathways, same outcome. This is convergent evolution. The same adaptive solution arrived at separately through completely distinct molecular routes, because the selection pressure pointing toward lighter skin in low UV environments was so strong and so consistent that evolution found the answer more than once. When nature keeps reinventing the same thing independently, that's as clear a signal as biology ever produces. Let's also talk about blue eyes for a moment, because the timeline here is genuinely shocking. Every single blue-eyed person alive on Earth today descends from one individual. One. A single person somewhere near the Black Sea region, approximately 6,000 to 10,000 years ago, who carried a mutation reducing melanin production, specifically in the iris. Before that individual existed, every human being had brown eyes. Without exception. Brown, all the way back. Then one mutation appeared and spread, likely because it was genetically linked to skin pigmentation variants already under strong selection pressure. Something that feels as ancient and fundamental as eye color, something that has been used to categorize and divide people throughout all of recorded history, is younger than the domestication on of the horse, younger than Stonehenge, younger than the wheel. We treat certain human features as timeless and primordial when they are, in any meaningful geological sense, basically brand new. The full picture looks like this. Skin color is a UV calibration system. It's a dial your ancestors' bodies tuned over thousands of generations in response to the specific latitude they lived at, the specific sun they worked under, and the specific food they happened to eat. Light skin isn't superior. In equatorial environments, it is actively dangerous, increasing cancer risk, increasing folate destruction, undermining reproductive success. Dark skin isn't primitive or less evolved. It is the ancestral configuration, the original, the baseline from which everything else is a deviation. Lighter skin is the modification, the adaptation, the newer version. And the deepest irony woven through all of this is that the same sun drove some populations toward maximum melanin and drove others toward minimum melanin, for completely opposite but equally urgent reasons, without preferences, without agenda, just physics and biology and the cold, indifferent math of who survived long enough to have children.